This is a Mothra type model again, where you've got an arch kite. Um, this time, instead of the kixels, and that would be the top parts normally, the top line. Instead of them just being well foiled or flat panels, uh, to steer them, I've added this component on the bottom, this sort of gill, sort of sail, almost like a flip wing on or sail or something, um, and yeah, like ribs on a single skin parafoil almost. If they are also lined as we've had load paths to take the full load of every kixel, what we've done here is almost a similar load path, but adjusting each one of these paths. Um, if I say take the back line and pull it out the way, or take that's the lower line, pull it this way. You'll see what that's done is make all of these slightly angled so that the deflective force, um, even without lift, is pulling the whole kite up to the right there. After having done that, now it may be that there's a more optimal configuration than just those flat layers. You might want some sort of scooped out, three different panels to make up the shape instead of just two different panels like I've got here. And this model, as you see at the moment, isn't holding perfectly the form that the stretch would take in the end. Yeah, once you've got it pulling up to the right, in order to tap power from this, what I suggest is, so imagine we're pulling away from these dots here. If these are all mounted on a bar and able to feed and mount separately, either say the front one goes forward, or that front one moving would change the aspect of the whole lot. So if the front one goes forward, that would tend to make the kites pitch away, so they would pull. Now, my preferred thought at the moment on this is that they would all be mounted on a bar around about here. You'd have another bar around about here. I'll sketch this in a wee second, and I'd put small gears here, and so each of these sprockets would have a chain going around it in sequence. So when this bar was lifted, you'd have a multiplying force, basically, just like a block and tackle, really. And the last sprocket would run to a flywheel mechanism, drivetrain of, say, a rowing machine. And instead of the flywheel, you'd have say an electric assist bike hub round about there. So yeah, the chain recoil from the rowing machine would be great for setting this, pulling this back down. Once you've got your maximum stretch here, and you've pulled all of this chain out and driven that bike hub, then you've got to find a way to get this to go back the way. So it's either you're going to have like some string pull it back in, or you're going to have a cog go out the side to set these two. But because you're going to want to mirror the signal on the other side as well. So as soon as you pay out on this side, you want to pull in on this side to flip the whole thing backwards. The good thing is, if you are working with a belay line, now this is this is obviously going to be a small scale. This is like a human scale. Two people pedal off with a bike and tie it to the bike components, when they're camping or something. But if each one of those was like a 6-meter kite or something, that would probably hold quite a bit of power. If this is in a belay circle here, you can easily tighten all the way across that gap. You can set devices to run along round in the circle, and you can also stretch a signal cable across the bottom, or even part way up the loop. But you can get the tension across here in order that when a part moves here, the opposite happens on the other side. So you've got steering going to one side there. Once it's tripped, it's gone over, it's reached its maximum. Both of those go back and then go the other way. That's quite good, I reckon. Could be a goer.